Hi, my name is Gitan Karnam, and I'm a current student of the graduate student of the University of Florida. And this video is regarding my pattern recognition project. So throughout this video, I would be giving you a walkthrough of what my project is, how it has been implemented, and the results that I found out. So let's get started. The problem that we are facing today in image detection, or rather you can say when we are tracking image or tracking motion in real time video. So the problem is that the systems that currently exist have quite good complexity, like a quite good computational complexity, and these systems are difficult to be implemented on small systems like pervasive systems for IoT solutions which contain microcontroller boards like Raspberry Pi. So these systems or some computational analysis have to be compromised, but yet get good results for these kind of systems. So we would first go about the related work that has been done. So there are basically two kinds of approaches to motion detection. One kind of approach is the object segmentation, and another kind of object approach is motion segmentation. Now, what happens in object segmentation is a process. Object segmentation is basically a process of partitioning a digital image into multiple segments, and these segments contain individual objects. So it helps to determine the different entities that are present in the frame. So each and every entity can be identified separately. Now, some of the object detection algorithms that have been implemented or do exist are the dominant motion analysis, MRF modeling, and the Bayesian methods. The only disadvantage that object segmentation has is the performance is limited by accuracy of motion estimation. That means that in the process of detecting each and every object and entity separately, somewhere we compromise the detection of motion, which is our primary objective. Now, the another type of approaches are motion segmentation approaches. Motion segmentation separates regions of trajectories from a video sequence into coherent subsets of space and time. Here, the pixels are segmented depending upon its relative movement over a period of time, that is, the time of the video sequence. Now, some of the approaches are temporal image difference based methods or motion based methods. But the disadvantage that the motion segmentation approach has is that it fails to detect some kind of objects, or rather, it is unable to detect some kind of objects in the real world environment. So the project implementation is done using a laptop webcam, and the code is executed in Ubuntu environment. The code is written in Python, and the OpenCV support, which is extended for Python, is used to handle the video frames and do the necessary computations. To go about the working and the implementation, I first give you the overview of the flow of the code. So when- so we need a first frame. The first frame is your static background. It can be anything. It can be your office. It can be that you are monitoring a door in your office, or probably your desk. Something which is static and does not change frequently with a fixed camera. So that would be your first frame. There can be minor changes in the background, of course, but these changes can be handled using the threshold that we specify. Next, we do is that we grab each incoming frame, convert it into grayscale, and apply Gaussian smoothing. What Gaussian smoothing does is sometimes what happens is because of some kind of noise, a different kind of lighting, or because of shadowing, there is some changes in the pixel intensity. So basically, when you calculate the absolute difference, so that gives you a certain value, probably, which the system would not understand. So it has to be blurred and filled. Next, we do is that we compute the absolute difference between the two frames. So the absolute difference, if it is greater than a particular threshold, then we need to find the contours for that. So we compute the bounding boxes for the contour and draw it on the frame. So to start with the working of the project, so the initial state of the project is shown as in the background, and there are three windows that are used. So the first window gives us the view from the basic view, that is the initial static background that we would be using. The second window is the delta window, that whatever the absolute difference between the two images or between the two frames is calculated would be shown in the delta window, and the threshold window shows any changes that is over the threshold value. To go about the next part of it is that we start by taking the absolute difference between the frames to see where in the frame exactly the motion occurs. So as we take the absolute difference between the first frame and any new incoming frame, we get to know that there is a certain, or there is a particular object, or there is some changes in the frames, some major changes in the pixel intensities, which help us to find that there are objects present in the frame. So the threshold frame helps us to know the pixel intensities or the changes that are above the threshold value, and that helps us to detect the contours and draw our bounding boxes on the frame. So to detect a motion, suppose the person moves. So if the person moves, then the size of the bounding box expands. That is again based on the absolute difference and the values above the threshold from the frame that was from the original background frame. Now, since there is a motion, we have to accommodate we have to accommodate the bounding box, we have to accommodate the motion within the bounding box. So is the bounding box expands or shrinks depends on this motion or how the object size differs. An object cannot differ by its own, so obviously it is the motion that changes the bounding box size. Now we have to detect each and every entity in the frame differently. Each and every entity in the frame is as shown that the webcam, when sees, again we compute the absolute differences, and each and every has shown the two bottles and the person standing can be detected differently. There are some factors that have been compromised. For example, consider this slide. The person standing is in between the two bottles. If the person is standing too close to the red color, to the pink color, or to the green color bottle, then the entire bottle is contained within the bounding box of the person. That means the bounding box expands to accommodate both the entities, and these entities are considered as one. These are some factors which are compromised for to reduce the computational processing. So due to shadowing and improper lighting, there is possible that the random bounding boxes may appear. Suppose, for example, in my project, I specify the threshold of 25. Suppose the threshold is less for a different environment, and there are some changes in the lighting, and because of that, there are changes in the pixel densities from the first frame. So the absolute difference may be more and above the threshold value, so these changes can be detected as objects, and probably bounding boxes may appear in the frame. So the threshold value has to be fixed properly. We know that the low value will detect unnecessary objects, and high threshold will fail to detect a few significant objects that we know. So depending upon the lighting conditions, the shadowing, and the backgrounds, we have to properly set the threshold value for that. This project has been successfully implemented and can be easily implemented on embedded systems with Raspberry Pi or which have fixed standalone cameras, as the processing power and the computational computation complexity of this system is not much. So motion tracking, as we all know, finds application in various fields. It can be used for video surveillance, for intrusion detection. It can be used in the field of sports to track a motion of player, or it can be used for law enforcement to detect number of vehicles at a toll booth, or to detect accident at junctions, and other pervasive systems or IoT solutions. I would now give you a demonstration of the running project on the Ubuntu environment.